Okay, finishing the section 1.1 and 1.2 lecture notes, we're looking at this question. It says, find all points on the y-axis that are 6 units from the point 4, -3. So just kind of put your head, think about this for a minute. We want, these points are on the y-axis. Remember, this is the x-axis and this is the y-axis. So we know they're along the y-axis. So if they're on the y-axis, that means the x-coordinate is 0 on the y-axis. Any point, if you think about any point on here, the x-coordinate is 0. So we have this point 0, y. Now we want it to be 6 units from the point 4, -3. So 4, -3 is the point that we want this point to be 6 units from. So our distance there is 6. Okay, and so we can answer this by using the distance formula. We've got the square root of x2 minus x1, which is going to be 4 minus 0 squared, plus y2 minus y1, which is y minus -3 squared, or actually, if I want to be consistent, -3 minus y squared, and that's equal to 6. And so what we can do here is square both sides, and then here 4 minus 0 is 4, so this is 16 plus -3 minus y squared is equal to 6 squared, which is 36. So I squared both sides to get rid of the radical, and then I just cleaned up here. Then what I do is move the 16 over, so I have -3 minus y squared is equal to 36 minus 16, which is 20. And so then I have -3 minus y is equal to, in order to solve this, I need to get rid of the square root, so it's plus or minus the square root of 20. And so this is -y is equal to either positive square root of 20 plus 3, because I'm moving the 3 over, or -y is equal to negative square root of 20 plus 3. And then finally, you divide through by this negative, and you get y equals negative square root of 20 plus 3, or sorry, minus 3, because you're dividing through the negative all the way through. Or it's going to be y equals, that'll be positive square root of 20 minus 3. Okay, so dividing through by the negative is going to change the sign on each of those. Now you can actually simplify the square root of 20 because 20 is 4 times 5 and 4 is a perfect square. The square root of 4 is 2. So this is going to be y equals -2 on the square root of 5 minus 3, or y equals 2 on the square root of 5 minus 3. So, and those are your, and so I guess if you want to put it in point form, we would say on the y-axis, so it would be, the x is 0, so 0, -2 square roots of 5 minus 3, and 0, 2 square roots of 5 minus 3. So that's kind of a messy problem, but that is that's the exact answer there. Okay, the other thing that we didn't get to in the lesson was talking about these tests for symmetry. And so I'm going to go ahead and finish up these last 4 problems where we test for symmetry. The way you test for symmetry, for x-axis symmetry, you replace y by -y and simplify the equation. And if the equation results in the same thing that you had when you had y there, then you have symmetry with respect to the x-axis. And then you kind of do the opposite with y-axis symmetry. You replace x by -x, clean it up, and if you get the same thing that you started with, then you say that the graph is symmetric with respect to the y-axis. Now, to get origin symmetry, you have to replace x by -x and y by -x and simplify. And if you get the same thing as when you have x and y in there, then you have symmetry with respect to the origin. And it turns out that if you prove that you have both x and y axis symmetry, you immediately have origin symmetry. So that's just kind of interesting. Okay, so let's look at this problem. Let's check for x-axis. So the way you check for x-axis is plug in -y for y. Okay, so instead of y squared, you're going to have negative y squared is equal to x plus 9. But negative y squared is in fact the same as y squared, because when you square, a negative just becomes positive. So this is y squared equals x plus 9. Well, that's exactly what you started with. So yes, you do have x-axis symmetry. If you try y-axis, you're going to plug in negative x for x. So you plug negative x in for x, or you replace x by negative x. Well, if we do that, we'll get y squared equals negative x plus 9. And there's no simplification that you can do that will make it look like what you started with. So that is not equivalent. So no y-axis symmetry. And you also, since you don't have y-axis symmetry, you don't have origin symmetry because you have to have both x and y. But you could kind of, imagine that if you put a negative y in and a negative x in, you're not going to get exactly the same. So no origin symmetry occurs on this one either. Okay, let's try this one. This one looks like a more exciting one. Okay, we have 9x squared plus 4y squared equals 36. All right, so we'll try x-axis first. And the way we do that is we replace y with negative y. So we have 9x squared plus 4 times negative y squared equals 36. And you should start to see, well, hey, if I'm going to square what negative y, that's going to be exactly the same as just having y in there. So this equation cleans up to be what I originally start with, or the equivalent. And so yes, I have x-axis symmetry. Let's try y-axis. Okay, with y-axis, you're going to replace x with negative x. So you're going to do 9 times negative x squared plus 4y squared equals 36. And you should be saying to yourself, hey, that looks a lot like the x-axis one, except it's the x instead of the y. But anyway, negative x, when you square it, it's the same as x squared. So this is 9x squared plus 4y squared equals 36. And so you have yes there to y-axis. And if you have both x and y-axis symmetry, you also have origin symmetry. So now you can say yes, origin symmetry. So this one has all of them. It has x-axis, y-axis, and origin. Now it depends where you studied in high school or before, but this is actually an ellipse. And it's like a little football that's centered on the origin, and so it does actually, you can convince yourself if you looked at the graph that is a symmetric, has all the symmetries. But we don't have to worry about that right now for this class. Just a little extra information. All right, how about x cubed minus 81? Well, let's try x-axis. If I plug negative y in, I'll get negative y is equal to x cubed minus 81. And if I try to simplify that, I could divide 3 by negative 1, and I'll get y equals negative x cubed plus 81. So that's just no. I mean, it's not the same. It's not equivalent. So you have no x-axis symmetry. If you try y-axis, you'll put negative x in. So you'll get y is equal to negative x cubed minus 81, and when you cube a negative, the negative you retain it, so it's negative x cubed minus 81. That's kind of how it simplifies, which is also a no. It's not equivalent because it's not just x cubed. Now let's replace with negative x and negative y. So now for origin, we're going to replace x, y with negative x and negative y. All right, well, let's see what happens. We'll have negative y is equal to negative x cubed minus 81. So we have negative y is equal to, this is just going to clean up to be negative x cubed minus 81. And then when we divide through by -1 here, we're going to get y equals x cubed plus 81. Which it was looking pretty good when we got that x cubed, but then the plus 81 messed it up. So this is also a no. We don't have any symmetry. So in fact, this graph has no symmetry. And if you were to look at the graph, like on your graphing calculator, I have to change my mode here to function. And then I go to y equals, and just look at x cubed minus 81. The window on that, you're going to need to, it's shifted down, so we can go like -5 to 5 on the x, but it's shifted down 81 units. So we could go like -100 to a +100 on the y. And let's make our y scale like 10, so each tick mark is counting by 10. And when we graph that, we can see that you don't have any kind of symmetry there. You don't have origin symmetry. You don't have x or y axis symmetry. Maybe a better window would be like -300 or -200. Let me try that. 200. Yeah, you can see you don't have any kind of symmetry. So that's that one. Okay, let's do a fraction one. Let's see how this one is. Let's try x-axis. So for x-axis, we're going to put -y in. We'll replace y with -y. So we have -y equals x squared minus 4 divided by 2x. Now if you clean this up, to simplify here, you're going to have y equals, you divide through by -1, which is just going to be like -1 times all of this. Which really just goes on to onto just the numerator. So this is -x squared plus 4 is another way to think of that, divided by 2x. And that is not the same. It's not the same as what you started with. So you don't have exactly opposite. Now let's try y-axis. I mean, you don't have, sorry, not exactly opposite. You don't have exactly the same. So let's try y-axis. So for y-axis, we're going to put -x in. So we have y equals -x squared minus 4 over 2 times -x. So this is going to clean up. Our top will be x squared minus 4, but our bottom will be -2x, and that is not the same. And so this is a no. And so by now you probably know that the origin symmetry is not going to work, because if you don't have x and y, you're not going to have origin. But you can replace, for the origin, you can replace y with -y and x with -x, and see maybe if it'll work. And so let's see, this is going to clean up how. So we'll have -y equals, that -x squared will just be x squared minus 4 over -2x. And now actually this one, this is actually going to clean up nicely if you cross multiply here, or just factor the -1 out of this fraction. -1 equals x squared minus, or sorry, how about we just divide through by -1 here. You actually will see that you're going to cancel with this negative here, and you do get x squared minus 4 over 2x, which is what you started with. So this is a yes. So even though I said if you don't have x and you don't have y, you won't have origin, that's not actually true. In this case, this is kind of a unique one. It does appear that we have origin, but we don't have x or y. But it is true that if you have x and y, you automatically have origin. So let's go in and look at this graphically and see if we can see that origin symmetry. X squared minus 4 divided by, when you do the 2x, make sure you put it in parentheses. Whenever you have a product in the denominator, you always want to put that in parentheses. And let's just try a standard viewing window. So I'm going to do zoom 6, which is the 10 by 10. And on this one, you can see that symmetry across the line y equals x, or we call that origin symmetry. Like, for example, if you go to the table and you put in like -2, you get 0. If you put in 2, that's not a good example, you get the same answer. Let's see, how about, let's see, if I put -5 in, I get -2.1. If I put 5 in, I get +2.1. So you can see that origin symmetry is occurring there. So we actually, clarifying some things there. If you have x and y axis symmetry, then you have origin symmetry. But it's not necessarily true that if you have neither x or y axis symmetry, you may still have origin symmetry. So you want to check that as you work these problems. Okay? Well, you guys can get busy on your homework now.